projects. In this video, we are going to explain about the project titled Comparative Analysis of Machine Learning Models for Performance Prediction of the SPEC Benchmarks. Introduction. The project centers on leveraging machine learning models to predict computer system performance, specifically focusing on the SPEC benchmarks. The primary objective is to accurately forecast performance scores based on system configurations without the need to actually run the benchmarks. This predictive capability is valuable for optimizing system design and resource allocation. The project's goal is to predict the performance of computer system using the SPEC CPU 2017 dataset. By analyzing this dataset, the project seeks to find the most effective methods to predict how well these systems perform. This insight aids in developing and designing systems that operate efficiently and deliver optimal performance. Understanding the impact of various hardware and software features in computer system performance is vital. This knowledge allows for the construction and design of systems that operate faster and more efficiently, ultimately leading to resource saving in terms of time and effort. It's about creating systems that work at their best based on a thorough understanding of their components and their performance implications. Objective. The primary aim is to create precise predictions of computer system performance using the SPEC CPU 2017 dataset. By analyzing this dataset, the project seeks to comprehend how different hardware and software features influence system performance. This understanding is critical for designing systems that perform optimally based on the configurations. Various algorithms including multitask elastic net, decision tree regression, random forest regression, MLP regression, voting regression, and static regression are employed. These algorithms are essential as they enable the analysis of data patterns and relationships. By leveraging historical system performance data and features, these algorithms aid in accurate predictions, helping us identify the most effective approach. The ultimate project goal is to construct a reliable predictive model for system performance. This model should minimize prediction errors, enhance accuracy measured by R2 score, and provide valuable guidance for future computer system designs. Achieving this objective contributes to improved efficiency and increased power in computer systems, ultimately advancing technology and computing capabilities. Requirements. The requirements of the project are hardware requirements, in which we have operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements, in which we have Anaconda 3 and Visual Studio Community version. Flow of project. To implement this project, we have designed the following modules. The first module is importing the packages. This module involves importing necessary Python packages and libraries that provide functionalities essential for data manipulation, analysis, and visualization. In this project, importing packages sets the foundation for subsequent data exploration, processing, visualization, and model building. Exploring the dataset. SPEC CPU 2017 data. This step involves delving into the SPEC CPU 2017 dataset to understand its structure, features, and contents. Exploratory data analysis (EDA) helps in gaining insights into the data, identifying patterns, and understanding the potential features that could influence the performance prediction of the SPEC benchmarks. Data processing, in which we have dropping the unwanted columns using Pandas framework and dropping the null rows using .drop function. In this module, necessary columns that do not contribute to performance prediction are removed using the Pandas framework. Additionally, rows with missing or null values are dropped to ensure data quality. Proper data pre-processing sets the stage for accurate analysis and model development. Visualization using Seaborn and Matplotlib. Visualization using Seaborn and Matplotlib involves creating graphical representations of the data, such as plots, charts, and graphs. This step provides a visual understanding of the dataset's characteristics, distributions, and relationships, aiding in identifying trends and potential features that influence performance. Feature selection with data ilog or particular column. Feature selection is a critical step where relevant features that strongly influence system performance are identified. This can involve selecting specific columns of features from the dataset using iLog that are essential for building accurate predictive models. Feature selection algorithm, in which we have using RFE with linear regression. Recursive feature elimination RFE with linear regression is a feature selection algorithm. It helps rank the importance of each feature and iteratively eliminates the least significant ones. Utilizing this algorithm, the project aims to identify the most impactful features for predicting SPEC benchmark performance. Building the model along k-fold validation, in which we have multitask elastic net. Multitask elastic net is a regression model suitable for dealing with multiple related tasks simultaneously. Building the model along with k-fold validation ensures robustness and reliability by validating the model's performance across different subsets of the dataset. In this project, it's a key step in establishing the predictive power of multitask elastic net for performance prediction. Decision tree regression. Decision tree regression involves using a decision tree model for predicting continuous values. It segments the dataset into subsets based on feature values and predicts the target variable within each subset. It's part of the comparative analysis to evaluate its effectiveness in predicting SPEC benchmark performance. Random forest regression. Random forest regression is an ensemble learning method that constructs multiple decision trees and combines the predictions for improved accuracy and robustness. This module evaluates the effectiveness of random forest in predicting SPEC benchmark performance, comparing its performance with other models. MLP regression, DNN. Multi-layer perceptron. MLP regression, a form of deep learning using a multi-layer perceptron, is employed to capture complex patterns in the data. Deep neural networks, DNN, are known for their ability to model intricate relationships. This module explores the potential of DNN in predicting SPEC benchmark performance. Voting regression. Decision tree plus MLP plus KNN regression. Voting regression is an ensemble technique that aggregates the predictions from multiple models, that is decision tree, MLP and KNN regression, and averages them to obtain a final prediction. This is a comparative module to assess if combining predictions from diverse models enhances overall prediction accuracy. Stacking regression. Rich plus SVR plus MLP estimators. Stacking regression combines multiple models, rich SVR, using a meta-estimator MLP to achieve better prediction performance. This module focuses on evaluating the effectiveness of stacking these models for predicting SPEC benchmark performance, especially given its reported better performance compared to other models. Training the model. This module involves training the selected models on the pre-processed dataset to learn the relationships between features and performance. It's a crucial step in model development, allowing the models to understand and optimize their parameters to make accurate predictions. Building the model with stacking regression, since it gives better score and less MSE comparing with other models. Stacking regression is selected for building the final predictive model due to its reported superior performance, better score and less mean squared error when compared to other models. This step focuses on integrating the models effectively for improved predictive accuracy. Flask framework with SQLite for sign-up and sign-in. Flask is a web application framework and SQLite is a lightweight database. This module sets up a web application where users can sign up and sign in, providing a platform for inputting feature values and receiving predictions related to SPEC benchmark performance. User gives input has feature values. This module involves users providing input by specifying feature values related to computer systems. The input data is pre-processed to ensure it aligns with the model's requirements for prediction. The given input is pre-processed for prediction. The trained stacking regression model is utilized to predict SPEC benchmark performance based on the pre-processed user input. The model applies its learned patterns and relationships to make accurate predictions. Trained model is used for prediction. Final outcome is displayed through front end. The final predicted outcome is displayed to the user through the front end of the web application. This provides user with insights into how the specified system configuration might perform based on the predictive model. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is the model file which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the code folder path from the address bar of the file explorer. I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I am typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, which is this, and port, which is this. Now copy this local link. I am copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. This is the home page of the project. This is the front end built using Flask framework. Now click on sign up button. If we are a new user, we need to register first, but I have already registered, so click on sign in button. This is the login form. Here we need to enter the username and the password which we have created. So I'm entering the username and the password and click on login. This is the home page of the project. So here we need to fill these information to predict the system rating based on SPEC CPU 2017 benchmark, and then we will get the performance of the system. So I'm entering these details. So here I have entered all the details. Benchmark, which is CINT 2017, number of courses 18, number of chips is 1, memory is 64 GB, storage is 960 GB, and peak 600 peak is 9.95, 602 peak is 17.6, 605 peak is 26.3, 620 peak is 10.7, 623 peak is 18.6, 625 peak is 22.5, and 631 peak is 8.32, 41 peak is 7.66, 648 peak is 30.3, and finally 657 peak is 17.4. After entering all these details, click on predict. So here we can see we got the outcome. The system rating is 15.2 based on SPEC CPU 2017 benchmark, and we got the performance of the system, that is, the performance of the system is good. So here we can see that this system performs well. Now we will enter the other system details and find the performance of that system. So I'm entering the details of the one more system. So here I have entered all these details of one more system. Now click on predict. So here we can see we got the outcome. The system rating is 9.66 based on SPEC CPU 2017 benchmark, and we got the performance, that is, the performance of system is poor. So in this way, by entering the details of a particular system, we can predict the performance of the system, whether it is good or poor. The conclusion of the project is, the project involved testing and comparing various machine learning algorithms to predict system performance based on the SPEC benchmarks. Among these algorithms, the stacking regressor demonstrated the highest accuracy in performance prediction. By utilizing this advanced technique, the project significantly reduced prediction errors and enhanced the precision of the performance predictions, making it a standout approach. Through the utilization of these advanced algorithms and the identification of the stacking regressor as the most accurate predictor, the project lays a practical foundation for implementation in the field of computer system design and optimization. The predictive models developed in this project offer valuable insights for designing more efficient and powerful computing solutions. This empowers system designers to make informed decisions, ultimately leading to enhanced computer system performance and efficiency. The project's use of the stacking regressor proved to be exceptionally successful in guiding the development of superior predictive models for future system performance. By leveraging this regressor, the project significantly contributed to the optimization of computer systems. This suggests that the stacking regressor is a promising tool for future research and applications in performance prediction, paving the way for even more efficient and powerful computing solutions.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.